Okay, so today we're going to be going over the Module 4 review. So we're going to start off with, so here we have the two parallel lines, lines M and N, and the transversal T, and all your four angles on top, 4 angles on the bottom, so total of 8 angles. So let's start off by, first of all, labeling all our corresponding angles. So again, remember, corresponding angles are congruent. So first of all, angle 1 corresponds or is congruent to angle 5. So these go together. Okay, the next one's angle 2. So angle 2 goes with angle 6. And we have 2 more pairs. Start with angle 4. So angle 4 is right here, and that corresponds to angle 8. So 4 and 8 go together. And then the last one that's missing is 3 and 7. So there are 3 congruent to angle 7. Those are my 4 pairs of corresponding angles. And now using the same diagram, now let's label our alternate interior. So remember, alternate means they're on opposite sides of the transversal, and interior means they're between the two lines M and N. So here, they're congruent to each other. So angle 4 and angle 6 go together. So that's a pair of alternate interior angles. And then the other pair, again, that's inside in the interior, is angles 3 and congruent to angle 5. So those are the 2 pairs of alternate interior angles. Now, same side interior. Now, these angles are, again, it says same side, where they're on the same side of the line T, and they're in the interior or between the 2 parallel lines. And here they're supplementary, and again, that means their sum is 180 degrees. So here the 2 pairs are angle 4 and angle 5. So these two angles here, they have to add up to 180 degrees. And the other pair, 3 and 6, they also add up to 180 degrees. Those are your 2 pairs of same side interior angles. Okay, now, next one's the alternate exterior angles. And again, alternate means they're on opposite sides of the line T, and they're on the outside of the exterior of the 2 lines. So here we start off with angle 1. Again, they're congruent to each other. So angle 1, which is here, that's congruent to angle 7, which is down here. And angle 2 is congruent to angle 8. So those are your 2 pairs of alternate exterior angles. And again, remember, all of these only work out, all these types of angles, if the 2 lines are parallel. Okay, so still working with the same diagram. What's given to you here, when you're going to work out a problem, they tell you that measurement of angle 2 is 75 degrees. So if you look at angle 2, being 75 degrees, that means that this angle here is 75, which means that this angle here is also 75. Okay, so these 2 are 75, which means that these 2 are also 75, because all 4 of those angles are congruent. So what they're asking you here is to find the measure of the remaining angles. So far, those 4 measure 75 degrees. So angle 4 measures 75, angle 6 measures 75, and angle 8 also measures 75 degrees. So what we have left over is we have 4 more angles. And we have to figure out what those two measure. So we have these right here, 1 and 3, and same thing with 5 and 7. So the way you find those is you just take 180 and you subtract whatever angle we had here. So it's 75. So 180 minus 75, that's going to give us 105. So that means that angle 1 is 105, angle 3 is 105, angle 5 is 105, and angle 7 is also 105 degrees. So that's a pattern that the angles follow when the two lines are parallel. Okay, now in this next example here, so we have two intersecting lines. So remember that these are congruent because they're vertical angles. So 1 and 3 are vertical angles. Same thing with 2 and 4. These two are congruent to each other. And they tell you in the diagram, angle 1 and angle 3 are both equal to 180 degrees. So again, if two angles are the same and they both add up to 180 degrees, we could say here that 90 and 90 equals 180. So that means that angle 1 is 90 degrees. Same thing with angle 3 is 90 degrees. That way, because they're congruent to each other, so 90 plus 90 gives us 180. So that means that these angles here form a 90-degree angle. So if you remember, if two lines intersect and they form a 90-degree angle, it means you can put a little box here, the square, to say that 90-degree angle. So remember, if two lines intersect and they form a 90-degree angle, we say those lines are perpendicular to each other. So when I ask you, what can you conclude about lines M and L? Our conclusion, we could say the lines are perpendicular since they form a right angle. Okay, so let's get into the next example here. So here we have another problem dealing with perpendicular bisectors. So what's formed here, okay, add this to your diagram, that forms a 90-degree angle. So again, remember, it's a 90-degree angle on all four corners. So in this problem, they want you to solve for segment AR. So segment AR is that segment right there. So it forms this triangle right here. And again, remember, we're going to be using the Pythagorean theorem to solve for that segment. So we know that this side here, I'm going to call it A. I'm going to call this side B. And then AR, my longest side or my hypotenuse, is C. So I'm just going to substitute in the values where they go. So for A, I have 7, B, I have 6, and then for C was segment AR. Okay, so 7 squared gives me 49. 6, okay, that should be a 6. Sorry, I forgot to edit that. So that should be a 6 right there. 6 squared is 36, and AR squared stays AR squared. So on our next step, so now we have 49 plus 36 equals AR squared. So now we add the two values there, 49 plus 36. That gives us 85 equals AR squared. And remember, to undo a square, we take the square root of both sides. So I take the square root, and remember, a square root and a square, those eliminate each other. So these two eliminate each other. We're just left with AR. So here we say that segment AR is equal to the square root of 85. And that's our answer. Okay, let's go on to our next example using this same diagram. This time they want you to solve for segment RB. So here's segment RB. But if you notice this, because this is a perpendicular bisector, again, there's a 90-degree angle here. Both halves are congruent to each other. So we know what AR is from our first example, and it said that was square root of 85. So because that's a perpendicular bisector, that means both halves are equal to each other. So we say that since AR is square root of 85, AR is congruent to RB, so that means that RB is also square root of 85. So our answer here is that RB is equal to square root of 85. Oh, so that's our answer right there. Okay, let's go on to our next example. So in this case, we want to solve for segment RT. So RT is this segment right here. And again, this forms a 90-degree angle. So we have our triangle here. So this is again A, this is B, and RT is our C. Okay, so using the Pythagorean theorem again, we put in our values here. So we said A was 3, so we put 3 squared. B was 6, so 6 squared. And RT is the segment we're trying to solve for. So we leave it as RT squared. So now we have 9 plus 36 equals RT squared. Or 45 equals RT squared. And again, to undo a square, we square root it. So again, the square and the square root eliminate each other. So all we left was our segment RT. So we say segment RT is equal to square root of 45. Okay, now let's get into our last example using this diagram. So there we go. So that's square root of 45. So we're going to solve for segment ST. Okay, so let's figure out where our segment is at. It's right there. And again, this still forms a 90-degree angle. And it's on the bottom. So in all four corners, make a 90-degree angle. So again, we still use a Pythagorean theorem. But in this case, this is my A. This is B. And then ST is my C. So when I set it up, I have 3 squared plus 3 squared equals ST squared. Or 9 plus 9 equals ST squared. Or 18 equals ST squared. So we take the square root of both sides. Remember, the square root and the square cancel each other out. So I have an answer of ST equals square root of 45. Okay, so now let's get into the next part. So here we have two pairs of parallel lines. So they're asking which angles are all congruent to each other. So the first pair is, again, remember, they all follow the same order. So it'll be these right here, these right here, these right here, and then these right here. So just think of they follow the same orientation. So we just want to list them all. So it's angle 1, 6, 3, 8, 9, 14, 11, and 16. So all 8 of those angles are congruent to each other. So that's the first set. In the second set, and they go in the opposite direction. So we say these two, 2 and 5, 4 and 7, 10 and 13, and then 12 and 15. So you just want to list them all. Again, 2, 5, 4, 7, 10, 13, 12, and 15. Those 8 angles are congruent to each other. And again, remember, this only works out if the lines are parallel to each other. If they were not parallel, those angles will not be congruent. Okay, so now let's get into parallel lines. So it says write an equation that will be parallel to this one right here. Remember, when parallel lines, they have the same slope. But when the equation is written in this format, what we're looking for here is has to stay the same because same slope. So what I do here is this 3x and this positive 4y, those two have to stay the same. Only thing that has to change is this number in the end. So remember, these stay the same, but that 7, because you have to have an equation that's different, we can just put any other number here. And here I just picked an 8. So again, remember, these two are the same. So over here, this stays the same. Okay, so it stays the same. But this one, you have to change it. Yeah, so you just change the value. It could be any number, anything else. It could be anything. As long as the first two values stay the same. All right, let's go into the next example. We have negative 6x minus 2y equals 7. Again, we're going to write an equation that will be parallel to this. So again, these two values stay the same. The only thing that changes is that 7. So I have negative 6x minus 2y equals, again, it could be any number. In this case, I picked a 9. So that's my answer right there. Okay, now perpendicular lines. So again, we're going to write an equation that will be perpendicular to negative 6x minus 2y equals 7. So what you want to do here is just swap the values. So the negative 6x goes to the back with the y. The negative 2y, negative 2, it was with the y first, but now it goes with the x. And again, that last number, we just change it to something else. Here I put it as a 10. Okay, so perpendicular, they just swap. Okay, so, and let's go over another one. So again here, perpendicular to this one. Again, remember that 8 is going to go to the back with the y. The negative 3 is going to go to the front with the x. So you have negative 3x plus 8y equals, last number changes. So here I just made it a 7. You can make it any number you want, as long as the first two change and you still keep the same numbers, so negative 3 and 8. Okay, so now here's our, again, parallel and perpendicular slope. So here's my equation, y equals negative 4/3 x plus 5. So the only number you're focusing on here is the number in front of the x, because this is your slope. This is your slope. Okay, so that's your slope. So what I'm going to do here is, let me find my parallel slope first. And remember, it's the same slope, congruent slope. So my parallel slope would be negative 4/3. My perpendicular slope, remember, it's opposite reciprocal. So you take the reciprocal of the fraction and you change the sign, opposite sign. So here was negative, over here will be positive. So here I get 3/4. And then let's go over one more. Here's y equals 5x plus 5. Again, 5 is my slope. Okay, parallel slope, the same. So that was 5. Parallel slope would be a 5 as well. Okay, now for perpendicular slope, opposite reciprocal. So whenever they give you just a whole number without a fraction, just think of this as 5/1. So we take the reciprocal of that, 1/5, but we want opposite sign, so it would be negative. Okay, so we're done with today's notes. So now we want to start on your review, and I'm going to pass out right now. So again, so we're done with today's notes. And